Bonjour baddies, welcome back to another video. Today's first question is, what is the 100th digit to the right of the decimal point in the decimal representation of 3/7? So, when we are trying to find this, basically we're going to see, well, you don't really need to know how many times it loops around, but it's mostly on the remainder, because the remainder is how many more digits you have to count. So basically what I'm saying is, we're going to divide 100, since this has 6 digits, we're going to divide by 6, and that's how many times it's going to loop around. The remainder you have is how many it's going to be until you get to 100 digits. So it's basically like 40, and then you go 6 of 36. So it's going to loop around 16 times, and it's going to end up back at 4. So then you're going to count 4 more from the 4. Because 40 minus 36 is 4. And you're going to go 1, 2, 3, 4. Because the 16 is basically 16 whole cycles through the digits because they repeat. So 4 more is to get to the 100th digit, because at the moment we're only at 6 times 16 digits. It's not 100 digits yet. So the 100th digit is 5 in the numbers, because you can see this is the 4th one after you loop. Anyway, moving on to problem number 2. What simpler number does 0.9 with the bar equal? So when we're trying to solve this kind of stuff, wouldn't it be great to just get rid of the bar area and not have to calculate that? But legally, not oh, I don't want to do the bar anymore. You're 0.9. That doesn't work like that, unfortunately. But we can try to get rid of 0.9 with a number that is like 0.9, with the 0.9 with the bar behind it as well. So then we can subtract. So basically what I'm saying is, if we identify x as 0.9 with the bar, like so. Oh wait, that's over the 0 too. Just over the 9. Like that. And then we can identify, since it's a 1-digit loop, we can identify as 10x would be 9.9. And you might be wondering, oh my god, where is this going to go? If we subtract the 10x from the x from the 10x, and then the 0.9 with the bar from the 9.9 with the bar, then wouldn't we get 9x and then the number, and then we could solve for x instead of using the 0.9 with the bar? So if we minus it, we're going to get, this is legal by the way, legal in math, we're going to get a 9. So 9x is equivalent to 9. Since it's 10x minus x, which is 9x, and then 9.9 with bar minus 0.9 with bar, which is 9. So 9x equals 9, so x equals 1. So the simpler number that 0.9 with the bar equal is 1. And since you might be wondering, oh my god, but that's not true. They're two whole different numbers. In reality, if you look at the number, since the 0.9s go on in an infinite direction, and this is direct proof because this literally works with everything. But since the 0.9 goes, the 9 afterwards goes for infinity, there's really no getting a number to add to that to make 1. So 0.9 with the bar over it is 1, because there's nothing that you can add to 0.9 to equal 1, because it goes on forever. The 9s go on forever. Let me just highlight this in green. So yeah, that's the end of this video. I hope you guys enjoyed, and I hope you guys learned something new. And I will see you guys in the next one. Bye!